Chapter 13, Fluids. This lecture will help you understand pressure in a gas, atmospheric pressure, gauge pressure, and absolute pressure. Since air has weight, as does any fluid, it exerts pressure. The atmosphere exerts pressure on objects on the surface of the earth. Gas pressure is a measure of the amount of force per area that a gas exerts against containing walls. Here, the force exerted by the motion of molecules bouncing around. Temperature is a measure of the kinetic energy per molecule of a gas. Gas pressure is proportional to density. For example, air pressure and air density inside an inflated tire are greater than the atmospheric pressure and density outside. Twice as many molecules in the same volume means the air density doubled. For molecules moving at the same speed or the same temperature, collisions are doubled, therefore pressure is doubled. Pressure in a gas can be doubled by doubling the amount of air or decreasing the volume by half. Boyle's law is a relationship between pressure and volume for ideal gases. An ideal gas is one in which intermolecular forces play no role during collisions. Boyle's law states that pressure times volume is a constant for a given mass of confined gas, regardless of changes in pressure or volume, with temperature remaining unchanged. When we say that the pressure times volume is constant, it means that the pressure times the volume before the gas is changed must be equal to the pressure times the volume after the gas is changed. If the pressure of a gas is increased, the volume must decrease. If the volume is increased, the pressure must decrease. When you squeeze a party balloon to 0.8 times its initial volume, the pressure in the balloon, A, is 0.8 times its former pressure, B remains the same if you squeezed it slowly, C is 1.25 times greater, or D is 8 times greater. The answer is C, 1.25 times greater. Boyle's law, sweet and simple. P before times the volume before equals P after times the volume after. Taking the initial volume as 1 and the final volume as 0.8, we find that the pressure after is 1.25 times the pressure before. The atmosphere is an ocean of air surrounding us and exerts pressure. The Magdeburg hemispheres was a demonstration in 1654 by Otto von Guericke showing the large magnitude of Earth's atmospheric pressure. When the rims were sealed with grease and the air was pumped out, the sphere contained a vacuum and could not be pulled apart by teams of horses. Similar items are suction cups. By forcing the air out, the surrounding air pressure pushes against the suction cup and holds it to glass. Atmospheric pressure is caused by weight of air above us. Atmospheric pressure varies from one locality to another, so it is not uniform. Measurements of air pressure are used to predict weather conditions. Atmospheric pressure exerted against bodies immersed in the atmosphere result from the weight of air pressing from above. At sea level, it is 101,300 pascals, or 101.3 kilopascals. Weight of air pressing down on 1 square meter at sea level is around 100,000 newtons. So atmospheric pressure is 10 to the 5 newtons per meter squared. As altitude increases, air pressure decreases. Mountain climbers often must use oxygen tanks to help them breathe at high altitudes. Aircraft must have pressurized cabins for passengers to be able to breathe and function. When the air pressure becomes unequal, its force becomes quite evident in the form of wind. The pressure of the atmosphere can be expressed in terms of the pressure of an equivalent column of water or mercury. The density of water at 20 degrees Celsius, room temperature, is 998 kilograms per cubic meter. This gives a column of water 10.4 meters tall, which is around 34 feet. The density of mercury is 13,534 kilograms per cubic meter. This gives a column of mercury 0.76 meters tall, around 30 inches. Pressure at the bottom of a column of air reaching to the top of the atmosphere is the same as the pressure at the bottom of a column of water 10.4 meters high. The consequence is the highest the atmosphere can push water up into a vacuum pump is 10.4 meters. Mechanical pumps that don't depend on atmospheric pressure don't have the 10.4 meter limit. Air pressure varies with altitude because the air at ground level is denser, so there are more and more air molecules pushing down on the molecules below. At the altitude of Mount Everest, air pressure is 33 kilopascals. The air is so thin at this altitude, you need to carry oxygen with you to survive. A mechanical pump works when the piston is lifted, the intake valve opens and air moves to fill the empty space. When the piston is moved down, the outlet valve opens and the air is pushed out. A barometer is a device used to measure atmospheric pressure. It can also be used to determine elevation. As altitude increases, pressure decreases. An aneroid barometer is a small portable instrument that measures atmospheric pressure. Ground level atmospheric changes due to weather patterns. When an aneroid barometer is calibrated for altitude, then it can be used as an altimeter. Atmospheric pressure is caused by the A. Density of Earth's atmosphere, B. Weight of Earth's atmosphere, C. Temperature of the atmosphere, D. Effects of the sun's energy on the atmosphere. Answer is B. The weight of Earth's atmosphere. Two people are drinking soda using straws. Do they suck the soda up? Could they drink a soda this way on the moon? A. Yes and yes. B. No. They suck the air out and the atmospheric pressure pushes the soda up. Yes, they could do the same thing on the moon. C. No. The reduced air pressure in the straw and the atmospheric pressure pushes the soda up. No, they could not do the same thing on the moon. D. Yes. And no, they could not do the same thing on the moon. Answer is C. No, they reduced air pressure in the straw and the atmospheric pressure pushes the soda up. And no, they could not do the same thing on the moon. The moon does not have an atmosphere, so it cannot push the liquid up the straw. Pressure is measured using a gauge. Different types of gauges read either atmospheric or gauge pressure. When we purchase bottled gas, the amount of gas and its density vary with the pressure. If the pressure is low, the amount of gas in the bottle is low. If the pressure is high, the bottle is nearly full. The gauge that is usually used for checking the pressure in bottles and tires shows a reading of 0 at normal atmospheric pressure. The pressure of the atmosphere is not included in this reading. Thus, gauge pressure is the amount of air pressure excluding the normal atmospheric pressure, as when one uses a tire gauge. The actual pressure, called absolute pressure, is the gauge pressure reading plus the normal atmospheric pressure. The actual pressure, called absolute pressure, is the gauge pressure reading plus the normal atmospheric pressure.